Okay, let's go ahead and get started. I'm going to take a brief moment to pause, just so you all understand that you're a part of history right now. Because this is the first public presentation on Exchange Server 2013 that we've ever done. So this is it. So I'll stand here for a moment if you want to take some pictures. No, okay. All right, well, we only have an hour, so let's go ahead and get started. So for those of you who don't know me, my name is Scott Schnall. I'm a principal technical writer on the Exchange team at Microsoft. I write some of the product documentation. I have a very large team, so I don't write it all. I write the areas of high availability, site resilience, virtualization, storage, store, ESE, and some deployment stuff. So I'm pretty busy in my day job. But the best part of my job is getting to do stuff like this, to be the first person to talk to you about Exchange Server 2013. And even if you've already downloaded the software, and even if you've read the public documentation that we've released, and even if you were fortunate enough to be part of our technology adoption program where we told you almost everything and gave you regular builds of the product to work with, I'm still going to tell you stuff today that you haven't heard before. There'll be some stuff in this session that you haven't heard before. There'll be stuff in part 2 of this session that you haven't heard before. But the big stuff that arguably probably nobody else in this room knows is the stuff I'm going to cover later this afternoon in the high availability and site resilience session. And in fact, for those of you who are attending, as I've been telling people, that session is the last session of the day today. So I'm going to go a little longer with that session. That will probably be a 75-minute session. I understand that might not work with your plans. These sessions are being recorded, so if you can only stay an hour, that's fine. You'll see the recording later. But if you stay for the whole session, again, you're going to hear things that very few people outside the Exchange team even know about, including those folks who are in our TAP program, because some of the features the TAP folks simply haven't had a chance to understand or play with. So let's go ahead and get started. Got my contact info up there. Feel free to contact me at any time. Couple things about this presentation. If you were in Paul Dolly's link presentation, you saw this same disclaimer slide. Why the disclaimer slide? Well, software's not released yet. We're still working on it. Everything I tell you today might not actually happen. Okay? It might be completely different. Now, there's zero chance of that happening. I'm only going to tell you stuff that's actually happening. But it's pre-release and things could change. I may give you performance statistics. Those are based on early beta builds. Don't go start designing and architecting around those statistics. They're all pre-release, preliminary, caveated, et cetera, et cetera. This presentation is public. Anything that's in here you can talk about with anybody. It's a public presentation. It'll be available for download in about a week or so from the msteched.com website. If you can't wait that long, if you absolutely must have it, ping me ahead of time, and I'll be happy to send you a copy. Now, it doesn't mean I want all 200 of you to ping me and ask for a copy, just only those of you who can't wait. Okay, the agenda is pretty straightforward. I'm going to talk about the new architecture in Exchange 2013, and it's very new and very different from anything that we had before. And then I'm going to finish up by talking about one of our server roles, the client access server role. Remember, this is a two-part session, so we'll focus on the primary architecture in this session. Then we'll talk about CAS. The next part, part 2, we're going to briefly recap the architecture, and then we'll focus on Mailbox and the changes there. But as with all new releases, to put it into context, we like to start out with a little bit of history so that you can understand where we came from, where we're going, and why. Okay, so if you think about the evolution of Exchange, for those of you who ran older versions, Exchange 2000, Exchange 2003, and you've been running Exchange for a while, things are very different from them. The older versions was a very monolithic model. Okay, there weren't any server roles. When you installed Exchange, we threw all the bits on the box. And it was up to the administrator to then later on configure that server the way they wanted it. You know, check the box that says make it a front-end server and so forth. It's a very, very monolithic model. We also had a model where even though in some versions we had clustering available, we didn't have any data availability. We were relying on both the hardware stack and third-party replication technologies to provide us with data availability. So that was, 10 years ago. That's where we were. Since then, 2007, we came up with this new architecture where we created these server roles. And that was an evolution based on where we were with hardware at the time. Largely based on the recognition that when you looked at Exchange's functionality, particularly with respect to some of the workloads that we had and the state of the hardware that was out at the time, we were largely CPU constrained. There weren't a lot of CPU resources around that time. And when you think about the time at which we developed that architecture, back in the 2005 days, that's where we were. We had a very heavily utilized workload, but we didn't have the CPU resources. So we had this idea of coming up with server roles to take things like data access, data transport, data rendering, and data storage and split it out across the server roles in order to accommodate that. In 2010, we took things further. We evolved that architecture. We still had the same server roles, but we evolved the high availability area. Certainly, we had introduced continuous replication in 2007, but we evolved it in 2010. And we evolved from the clustered mailbox server into the database availability group and the new platform that we have for HA and SR. So where are we going next? To understand where we're going next, it's helpful to understand some of the challenges that we found in the previous architecture, which is what you're looking at now. This would be the 2007-2010 architecture, where we have the 5 server roles, 7 if you count network and an Active Directory, but 5 Exchange server roles. And when we first went down this path, remember again, back in 2005, we wanted to develop a very robust messaging system, but because of the state of the hardware at the time, we needed to separate out functionality and put it into discrete packages that we logically grouped into what we call server roles. Okay, that's where server roles were born out of. The idea was to have these loosely coupled server roles that administrators could deploy, any which way they want, in multiple combinations, and have an architecture that met their needs based on the hardware that they were using. If they already had the hardware, they had a good architecture that could split out the server roles. If they were buying new hardware that had more capabilities, they could combine everything together and so forth. Now, there was a lot of work we actually did in 2007 and 2010 to work around that and to address some of those issues. But what we found, though, is that our dream of these loosely coupled server roles simply wasn't realized. And in fact, we found we had done the opposite. We had created a system that had very tightly coupled server roles, not loosely coupled ones. Tightly in terms of versioning, for instance. We use RPC communication to communicate between all the server roles. And because they can be on separate servers, that can be remote RPC. It's not such a great idea. Also, in terms of functionality, the functionality was tied across the server roles. If I'm an OA user, someone using Outlook Web App, my version of Outlook Web App is not dictated by the client access server I'm talking to, but rather by the version of the server hosting my mailbox. So even if I have a 2010 CAS, if my mailbox is on 2007 mailbox server, I have the 2007 version of OA. So there were some versioning issues. And of course, the geo-affinity issues as well as a result of that. RPC over a WAN is not a good experience for many, many customers, particularly if you don't have the bandwidth. So those were some of the challenges. There were other challenges, and I'm sure all of you can speak to these. Exchange deployments can be complicated. Yeah, we give you the option with all these server roles, but we also give you a mechanism whereby you can combine them in multiple different ways. And that can be a problem. In 2007, it was very, very common for customers to deploy dedicated server roles. Very, very common. And that's largely because we didn't have the CPU power. In particular, we didn't have multi-core CPUs back then. Now we do. So that problem was largely addressed in 2010. But still, many customers still deploy separate server roles instead of our recommended multi-role deployment. That can make things complicated. On top of that, load balancing is difficult. And when you think back at the history, Exchange has had a history with each new introduction of a version of adding a little bit of complexity with each version. In 2000, it was AD. 2007, it was certificates was the big hot button. In 2010, it was other things and so forth. In 2010, largely part of it was deployment, but the bigger one was the load balancing aspect. We introduced the RPC client access array. That introduced the need for load balancers that can do session affinity or layer 7 load balancers. And when you think about the number of connections and the number of devices that are out there and the ability of a service like Office 365 to scale very, very large, you can start to understand in that old model, you're going to need a lot of load balancers in order to handle that configuration. So that could be a very expensive and challenging solution. I don't know how many of you have ever written iRules for F5 or tried to reconcile load balancer settings, particularly as new workloads come on. It's a very difficult thing to do. Another challenge is that for those customers who aren't deploying multi-role servers, they are often leaving hardware on the table. Their hardware, if they're buying new servers today, becomes either underutilized or in some cases completely unutilized. If I go buy a big hex core, Nehalem chipset type server that's very large, and I deploy individual server roles instead of multi-role, I'm leaving potentially storage slots unused. I'm leaving DIMM slots unused. There's CPU power that's being left on the table and so forth. So obviously, we have a goal where we want to more efficiently use the hardware. And then the last challenge, particularly for those of you who have multi-data center deployments, is the namespaces. If you have a DAG, a database availability group, and you extend that to 2 Active Directory sites, just to service that DAG, you need a total of 8 namespaces. And to further complicate things, 6 out of those 8 namespaces need to be under certificates as well. So those were some pretty heavily challenges. So what have we done? We've actually changed the architecture in part to address these challenges, but also in part to enable the new scenarios that I'm going to talk about. So we had one theme. Our overriding architectural theme was to come up with a building block architecture that scales to deployments of all sizes. So that could be the smallest on-premises deployment, or it could be the largest deployment that we could ever conceive of in Office 365. And in following this theme and in going down this path, we get an evolution of the server roles, we get network layer improvements, and we get versioning and new interop principles that take care of a lot of the challenges I just talked about. And the benefits you get, well, you get hardware efficiency. You'll see that we're able to more efficiently use the hardware even if you are deploying separate server roles, which I'll talk about in a moment. We also have deployment simplicity. It can't actually get any easier than this because, as you may have heard, we only have 2 server roles out of the 5 in Exchange 2013 RTM. So it's a much, much simpler deployment. We also have cross-version interop, and by that I mean if you deploy an Exchange 2013 CAS today, that client access server can serve 2013 clients, and it can also serve 2010 and 2007 clients. And it may surprise you to know it can also support future versions when they exist as well. So we can not only proxy down, but we can proxy up as well. And the last is failure isolation. You'll see how that we've re-architected things such that failures affecting an individual database will only affect that one database. You'll see how we've built high availability into the protocols themselves, not just into the database availability group. And you'll learn about the internal new processes that provide HA for those mechanisms. So what does it look like? Well, this can be a very confusing drawing here, but basically there's 2 building blocks, 2 server roles. We have the client access server role and the mailbox server role. When you have groups of those, we have different names. If you have a group of client access servers, we call that a client access server array. That is different from the array we had in 2010. In 2010, the actual name of the array was the RPC client access array. This is not RPC based. This is just a CAS array, a grouping of CAS. And then, of course, a group of mailbox servers that are grouped together for HA has the same name. That's a database availability group. So this is an evolution of what we've introduced previously. And so you can see the representation of the CAS array and the DAG on that drawing. What you also may notice on that drawing is that there's no layer 7 load balancer in there. It's just a layer 4 load balancer because we don't need session affinity anymore. We have an architecture such that the entire session state takes place on the one server that hosts the active copy of the user's mailbox. So you don't have to worry about session affinity with CAS anymore. You don't have to worry about having expensive layer 7 load balancing solutions that maintain session affinity or, for some cases, cookie affinity for some of your internet clients. And you just don't need that anymore. The result is that we have a very loosely coupled set of server roles right now. These two roles are very coupled, and they no longer require each other for full functionality. What do I mean by that? Well, in 2010, anytime you put a mailbox in an Active Directory site, you also have to include CAS and Hub. You don't have to do that in 2013. And that's not just because there is no Hub server role, but that's because we don't require a CAS in every site that has a mailbox anymore. Okay? It's a very different architecture. It's also loosely coupled in terms of versioning, because there's nothing happening on the CAS side in terms of rendering. CAS is just a protocol proxy. So from a version perspective, it's always served by the one server. And what that means is if you want to give somebody a new experience, you need only upgrade that one server. You don't have to upgrade the front end as well. Just their mailbox server gets them all that new functionality. In terms of user partitioning, same thing. They get the functionality driven by the bits on their mailbox server. You don't have to update the the client access server separately. That's a big, huge deal. And then you'll see in terms of geo-affinity, you'll see some incredible, awesome changes. First, we don't use remote RPC anymore. The only RPC communications that we ever do are locally on that box. And it's locally on the mailbox server. There's largely not much in the way of RPC communication on CAS. It's all happening on the mailbox, and it's all local. All the rest of the communication is either the real-time protocol for or it's SMTP for messaging, or it's MAPI happening on the store on the mailbox level as well. The other thing is from a geo-affinity is we give you the ability now to have a single global worldwide namespace. Okay? And that's without having to buy expensive GTM or expensive global load balancing technologies on top of that. That's another huge win that we have for you. Now, we have one tenet that we followed when we were developing this, other principles that we follow, but the primary tenet that we have is something that we call every server is an island. Okay, that means every server is independent. So we might have, for instance, this could be, for instance, RTM, and this could be something post-RTM at a later date. Doesn't matter. Okay, so what do we have? If you think about the protocol server agents, web services, proxy, the assistants, the transports, and so forth, that's one layer of functionality. Another layer would be the business logic layer. That's where we do all the thinking and all the working and whatnot. And then the storage layer. So this is how we would typically separate the functionality within Exchange. But if you look at the old model from Exchange 2010, and 2007 for that matter, we actually allowed cross-communication between these components. And that is what tightly coupled them together. It wasn't the fact that we just allowed it. We required it for functionality purposes. We had to allow the assistants to talk to the store so that the assistants could do their thing. We had to allow transport to talk to the business logic so that transport could execute that logic against messages going through the pipeline. We no longer allow this. We have a tenet that says every server is an island, which means all the processing that happens for a given request from a client, whether it's retrieving a message, submitting a message, doing anything, is all happening on the one server. And we no longer allow the cross-functionality to go across individual servers. If something needs to be communicated on server 2 through transport, server 1 transport talks to server 2 transport, and server 2 transport handles the local communication. This is banned. We no longer allow that cross-functional communication. And without that, it makes things really crisp and simple and easy and gives us a dedicated, well-known path that we know is always going to be good no matter what client we're coming from and no matter what protocol we're using. Okay, so big changes there. Now, let's look at it from a functional perspective. Again, going back to the Exchange 2010 architecture, you always had that layer 7 load balancer up at the top. Then at the client access and hub transport and unified messaging server roles, you had little bits and pieces of Exchange functionality across all of those. Things that would do rendering, things that would do authentication, things that would do proxy and redirection, things that would execute business logic, and so forth. And then, of course, down at the mailbox server role, you had the mailbox store itself, content indexing, and the assistants. So what we've done to break up this model is we've carved out some of the functionality from CAS, Hub, and and some of the mailbox functionality, and we've actually put it over in different places. So the client access server is now simply responsible for authentication and proxy, and in the case of redirection. That's all it does. It's a lightweight front-end protocol proxy that has no business logic, no queuing, no storage, no nothing. It's just a protocol proxy. Then we've taken the rest of that and put it in the mailbox store. So the protocol themselves, what we used to call client access server, what we used to call hub transport server, what we used to call unified messaging server, and yes, what we used to call the mailbox server, we now refer to them as services that run on the mailbox role themselves. And of course, the store is still there and the content index is still there. And the store, as you'll see in the mailbox, or part 2 of this, is extensible storage engine still. We're still using Jet, and it's still the same great Exchange database that you love. Now, what else have we done? Well, we made some major changes to the CAS role, so let's focus in on those changes. So the CAS role, it's still a domain joined machine. Okay, it's not something you're going to put in an extranet or in a perimeter network. It's a domain joined machine, so it's connected to the corporate forest, and it's largely comprised of 3 components. It's got the protocol proxy component in it, it's got the SMTP proxy component in it, and it has call routing component in it that allows it to do redirection. That is the only functionality that the client access server performs in Exchange 2013. It's basically an Exchange-aware proxy server. The requests that come to it from internet clients, regardless of if it's an Outlook web app or an ActiveSync or an Outlook Anywhere client, any of those clients, it knows those are Exchange requests. And it has what you might think of as layer 7 routing logic built in. And because it has the routing logic built in, and because the session has moved to a single server where we no longer need affinity, you no longer need a layer 7 load balancer. Again, it's just a layer 4 load balancer that you need in front of this. So it's very, very inexpensive and lightweight. It has all the logic. It knows where to send the request, whether it's an SMTP request or whether it's a user trying to access their mailbox. It does specific lookups, and it knows how to proxy that request to the appropriate mailbox server, whether that mailbox server is in the same site or located in a remote site. It can still proxy that request. So I mentioned the CAS array. This is different from the CAS array we had in 2010. In 2010, we had an RPC client access array. It was for domain-joined Outlook clients who are accessing Exchange using MAPI over TCP. Okay, you'll hear soon, in fact, I'll just tell you now, there is no MAPI over TCP anymore. Okay, we only do MAPI over HTTP, or we only do what we call Outlook Anywhere now. Okay, so that means your internal domain join clients will also use HTTPS to connect to CAS and have their requests proxied. And because there's nothing doing MAPI over TCP, we don't need an RPC client access array anymore. So that's gone. Doesn't exist in 2010. It's not an object you need to create anymore. But you still do want to create a CAS array so that we can group the CAS together as one load balance set. Part of it is for management purposes, because there are things that we do differently now with respect to CAS. CAS talking to a load balancer, for example. We're putting intelligence into the CAS, and we're working with load balancer vendors so that they understand that intelligence, so that we can do things like take a CAS server out of rotation, take it out of service to do maintenance, simply by running an Exchange commandlet that not only takes it out of service, but it also tells the load balancer that it's out of service for maintenance once the load balancers understand those protocols as we work with them. So those are the kind of changes I'm talking about. Now, it's similar in terms of authentication and being the connection endpoint that we had in 2010. But there's nothing on the CAS server that's doing anything for the end user other than inspecting the stream that they're sending and proxying it off to the mailbox server, wherever their active copy of their mailbox is. So it looks something like this. If you put the two of them together, again, it's a layer 4 load balancer on top. You've got CAS. We still use IIS, so you'll still have IIS there. And that's for the web stuff and the proxy and things like that, and remote PowerShell. Obviously, we still have POP and IMAP and SMTP and Then down at the bottom, we've got remote PowerShell, which is where the business logic is. So even though remote PowerShell can connect to a CAS, for instance, it will proxy that back to a mailbox because it's mailbox that has not just the business logic, but the configuration objects as well. And just as an aside, that does bring to light an important deployment change. I'll talk about that later in the deployment process. But basically, historically, we always wanted you to do CAS to be the first one installed. We don't want that anymore. Now we want Mailbox to be the first one installed. That's not a requirement, though. Nothing bad will happen if you do CAS first. The thing is, Mailbox has all the configuration objects. So you can't do anything until you have a Mailbox server in there. You could put a CAS in there, but if you try to open PowerShell and try to connect to it, CAS has nowhere to proxy it until you give it a Mailbox server. So we want Mailbox first, then CAS, then any other order at that point. Again, you're not going to harm anything if you get the order backwards, but it's good to know that we do have a specific order. So you can see, though, on Mailbox, in addition to having the database itself and so forth, it also has the other components that you would recognize from the other server roles. For instance, the endpoint POP and IMAP protocols that were formerly in the CAS are now part of the client access service that runs on the Mailbox server. The transport stack and the mail queue, which were previously part of Hub Transport, are now part of Mailbox, and they're run by the transport service. And similarly, there's no server role anymore. It's simply the service that runs, again, on the Mailbox server. Okay? Big changes, but kind of easy to understand because we've kept a lot of the same terminology. Hopefully, it won't be confusing for you using CAS for multiple versions when it means clearly different things. Now, from a protocol perspective, OA, Outlook, EAS, Exchange Administration Center, EAC, which is our new replacement for both the Exchange Management Console and the Exchange Control Panel, and PowerShell. All of those are HTTPS-based type clients, and all of those would be redirected, proxied rather, from the CAS to the Mailbox server, where, again, the Mailbox is located. For POP and IMAP, again, that's also a proxy. That will go ahead and get proxied on behalf of the client. Same with SMTP. That'll be a proxy as well. Pretty much the only thing that's not a proxy is There's no way to proxy communication because of the nature of the real-time communication protocol. So what happens is a device or a caller connects initially to CAS over SIP, and then they get a SIP redirect from CAS, which sends them to the component on the Mailbox server. So that is the one place that we will redirect. Now, we do also have the ability for an administrator to configure redirection as well. So if the administrator wants redirection to occur from one AD site to another AD site, that is still a possibility. You don't need that anymore because now we can simply proxy across, and because it's a proxy and because it's using the same internet protocol, it's not a heavy communication protocol like RPC, it's okay for the CAS to be in one site and the Mailbox to be geographically distant. They can be farther apart and still provide a very good client experience at this point. Okay, so this is the basic overall client protocol architecture. It does show you some of the components of Mailbox as well, but we'll talk about that in part 2. So I mentioned earlier we're supporting RPC over HTTP only. There is no more RPC or MAPI over straight TCP. Okay, and that's a good thing. Okay, it's a good thing because we don't have RPC latency that we have to deal with. Okay, the Outlook client can just talk HTTP to CAS. CAS can proxy that, and it does really, really well in low bandwidth and highly latent network environments. It also provides us with a very stable and reliable model. Okay, MAPI and RPC, again, very, very sensitive to network latencies. Okay, if the network's not just right for RPC, or worse, if you have some sort of firewall or filtering going on, or if you run into RPC interop or version problems, you know that using HTTP is going to be a better solution for you at this point. In addition, because the RPC session is always on that one Mailbox server, we simply don't have any need to ever do RPCs out to anywhere. So local RPC is a good thing. It's all happening local. It doesn't care that it might be a beefier protocol. It doesn't have to traverse the network. It's when you traverse the network and you're using remote RPCs that it starts to become a problem. And, of course, it gets rid of that namespace. Okay, so remember I talked about the DAG extended to 2 environments needing 8 different namespaces. Well, now we've gotten rid of 2 of them in that environment. You don't need the CAS array namespace in either environment. And anytime you move a mailbox, or you do a star-over, a switch-over, or a failover, and the mailbox changes Active Directory sites, and you get that message that says the administrator has made a change, that message is gone now. We don't have to worry about that because we don't have that interop problem anymore. So that means administrators can move mailboxes around at all times. They can move it back and forth between sites or all over the place. And the Outlook or the Outlook web app or the Active Sync or the POP or iMac experience doesn't change. And you don't have to give the user a new URL. They just keep going to the same place, and it just works. And basically the way it works is this. You're going to notice once you start running Exchange 2013 and Outlook 2013, you're going to notice that the profile has some different information in there. We no longer give you the server name in the profile. All that is abstracted. And in fact, what we do now is we're literally displaying the GUID for your mailbox. So when you do that request, you're actually requesting a GUID for your mailbox at whatever your domain is. Okay, and that's what it's going to look like if you look in connection status in Outlook. That's what it's going to look like if you use the remote connectivity analyzer. It's what it's going to look like if you capture the traffic or look in the profile and so forth. This is normal and expected. Do not be worried or put off by the GUID. And in fact, our expectation is that most end users will probably never see the GUID. Okay, because they won't have namespaces or certificates or all these moving parts that cause environmental changes that require them to do something on their client. All that stuff is gone. It doesn't happen anymore. So largely, they should never even need to go into their profile to see that. But if they do, it's okay. It's just a GUID. So CAS gets the request for this GUID at somedomain.com, and then first it does an Active Directory lookup to authenticate and find some information. Then it will do an Active Manager lookup to find out where the user's database is, and once it has that, it will simply proxy the request to the mailbox server that hosts the active database. Okay? Very, very simple stuff. Now, we still recommend you use split DNS, though. For those of you who aren't familiar, it's just a DNS configuration where you're using the same host names internally and externally. They simply resolve to different IP addresses. So obviously, mail.contoso.com is going to resolve to the VIP, the virtual IP, that's for your load balancer in front of the internal CAS array. Externally, mail.contoso.com would simply resolve to the IP of your reverse proxy and get in that way. But even though everything is using Outlook Anywhere now, from an Outlook perspective, we still want you to use split DNS, because if you give Outlook the external DNS, then it's going to go out the network and back in through the firewall and back in that way, which will still work. It's just not going to be the most efficient path. You ideally don't want your traffic traversing into your perimeter network and then back in the corporate network that way. You just want it to go from the corporate network to somewhere else in the corporate network. Split DNS is the easiest and most economical way to do that. So the connectivity flow, I'm just going to run through some of these just as some illustrations. I've already talked about how it works, and it's very simple. So again, the connectivity flow is a request comes in, goes through the load balancer, gets sent to the CAS server. The CAS does the authentication, it does the Active Directory lookup, does the Active Manager lookup, and then proxies the request to that server. Okay? So this is a local proxy request. Everything is happening right here. Now, let's say I have a second site, another AD site. So again, layer 4 load balancer in the beginning. I send the information. It goes to CAS. CAS does the lookup. And in this case, CAS says, oh, what you really want to do is talk to this site. Okay, so we go ahead and we talk to CAS on that site. And now we're talking to the mailbox server in that site. So as I said earlier, you can see you can still do that cross-site OA redirection if you really want to. But one thing that's different is, let's say you had another site. Now maybe you don't want to do cross-site redirection to that site. Why? Because you don't have a CAS in that site to redirect to. So the communication comes in, and this time it's going to be a proxy across that site. So now you've got some pretty good choices available to you. If you happen to have a couple sites that have really high bandwidth, really low latency, really good connectivity, then you might want to go for redirection. But if you don't, if you're like most customers where you've got a couple sites, but maybe the network's not as good as it should be, or the bandwidth isn't as good as it should be, or latency is higher than it should be, then you might choose to do the cross-site proxy instead. Okay, so now you've got choices you didn't have before. Now, let's look at it from a legacy standpoint. How many of you would be upgrading from 2007? Okay, how many of you would be upgrading from 2010? And how many of you would be upgrading from an earlier version, like 2003 or earlier? Okay, so for the 2003 folks, it's going to be a little harder because we don't allow 2003 in the same forest as 2013. So we always do this n-2, so 2013 can exist in the same org as 2010 and 2007. So if you're on 2003 right now, you might want to think about maybe upgrading to 2010 first and then going to 2013. That's an easier way because it makes moving the data easier. Or you can simply, if you wanted to, you could start a new forest for 2013 and then do a cross-forest migration as well. It's a little bit harder to do, but at least it's only one upgrade versus two upgrades. So your choice there. In a legacy environment, and I'm showing 2010 here, but the behavior would be largely the same for 2007 as well. So in the legacy environment, when it comes in, and this goes to what I was talking about earlier about the version interop that we have, I can go in starting talking to a 2013 CAS server, but if my mailbox happens to be on a legacy server, the 2013 server knows that, and it can go ahead and send that request over to the legacy server, in this case the 2010, which will talk the normal way to the 2010 mailbox server. So I don't necessarily have to hand out two URLs. I can just give the users one URL, and they can go to that. And the 2010 example is the best example because we no longer need the legacy namespace when you're going from 2010 to 2013. Now, we do need it for 2007. So those of you upgrading from 2007 to 2013, you will need a legacy namespace in there. It's something that we're trying to work on, but the plan of record now for RTM is that will be a requirement for migrating. But for 2010, you don't. We can just proxy or redirect right to it. Same thing with on the other site. Again, there's a 2010 CAS server across the site. I can go across the site boundary, send the request over to that, and do a cross-site proxy request to the mailbox server in the other site. Okay? And again, no legacy namespace, which means I didn't have to mess with certificates. I simply continue to use the same names I've used before, mail.contoso.com in this example. And of course, we can also do the cross-site redirect as well. So if the message comes in, or the request comes in, instead of proxying it, we can redirect it to the other site and do the full cross-site redirection as well. So full fidelity for proxy and redirection solutions for both 2013 across the board, to 2010, and 2007 as well. Again, the caveat being with 2007, you need the legacy namespace. Friday, I've got the deployment and coexistence session, and I'll walk you through exactly what you would need to do in those cases. Okay, but the namespace simplification, that's a big win. That's a huge win. Now you can literally use a single global namespace without having to buy that expensive technology that does the global traffic management, or GeoDNS. You can simply hand out one URL. And what we're doing, and I'll explain it in a moment, but basically what it comes down to is we're leveraging the ability of Internet Protocol clients to use multiple DNS IP addresses when they do the query, is largely what it comes down to. And I'll show you in some animation. But what that also means is that you don't have to load balance the namespace anymore. You don't need that layer 7 load balancing in the namespace. Any CAS in the CAS array inside the org can answer to that namespace. Okay, as long as it has the right certificate on it, it can answer to that namespace. So here's an example. Okay, and this example is just going to show you how round-robin DNS would be used. Okay, so I've got Sue. Sue's a mobile worker. She's somewhere in North America, and she travels around. And because we have a single common namespace, she only has to remember one URL, mail.contoso.com. Now, here's where the magic comes into play. Sue does a DNS request, okay? And what we're doing is we're leveraging her client. It could be a browser. It could be the HTTP stack driving Windows or a non-Windows platform. It could be Outlook. Whatever that calling client is, it's doing the DNS name resolution. And we are leveraging that client's ability to get multiple IP addresses back in return. So what happens is Sue does the DNS lookup, mail.contoso.com, the DNS server sends her back 2 IP addresses, one for the VIP in DC1, one for the VIP in DC2. And basically what will happen is Sue's going to round robin across these. She might bounce across both VIPs. She might bounce across within the array. But it doesn't matter. We don't need the same server to service that session anymore because the session is all located on that one mailbox server, not on CAS. So that means any CAS can service that request. Any load balancer can service the request. So she might start out perhaps working with VIP 1. Then maybe after a while, maybe the TTL, the DNS time to live, expires, and she does a new query, and now she's moved over to VIP 2 instead. Or maybe something happens with VIP 1, it goes away, the load balancer dies or something happens, it just goes out of rotation. When a DNS client gets multiple IP addresses back, and it can't resolve one of them, it will wait 20 seconds and try the other one. So if something happens to VIP 1, Sue doesn't have to do anything. Her client already knows the other IP address to try, so after 20 seconds, she'll try the other one and get connected. Or, again, it might be just the TTL expiring, or it could be her closing and opening the client, or anything that would cause it to change. Okay, that's a simple example. Now, let's extend that example. Okay, Sue actually works for a large company, and that large company has data centers in APAC as well. Now, here what we're doing is we're relying on magic from external load balancers. Okay, there are load balancers out there that, based on where the query is coming from, based on the IP address of the client sending the query, they will hand out a certain set of IP addresses. So if I'm in North America, that load balancer would hand me North American IP addresses. If I'm in APAC, the load balancer in APAC is going to recognize I'm coming from there and hand me addresses in APAC. So again, as an example, Sue might start out in North America, again doing DNS resolution. In this case, it's via GeoDNS. So the DNS server's looking at her IP address and then doing a lookup to figure out what IPs it should return based on that address. And because she's in North America, it only returns the IP addresses for the two VIPs that are in North America, in NADC1 and NADC2. Okay, so that's great. So she'll round robin between the VIPs. Again, she might be bouncing around the array, bouncing between the VIPs. It doesn't matter. It's not going to change her experience at all. She doesn't have to re-authenticate. She doesn't have to close or reopen any applications. She's not going to notice anything is happening. Why? Again, I hate to sound like a broken record, but because the session is all on the one mailbox server. So it doesn't matter if I switch CAS because the session persists on that mailbox server. It doesn't need to be torn down and reconstructed every time she changes CAS or every time she changes a load balancer. It just exists. So even if she gets disconnected from VIP 1 and then connects right up to VIP 2 and sends another request, the mailbox server simply sees it as a request coming from the same client it was just talking to. So there's no session for it to tear down and rebuild. It just takes the traffic and keeps moving, all seamlessly and transparent to Sue. Okay, now Sue's on the move. She's now traveling in APAC. So again, she fires up her laptop, fires up Outlook, or again, the web browser. She does the DNS resolution. This time, the DNS server recognizes, oh, you're requesting a resolution from an IP address that's in APAC. So because you're in APAC, I'm going to send you only IPs from the APAC VIPs. Okay, so now Sue can round robin between those and, again, have the same exact experience she was used to in North America. And as she does that, again, you can see what's happening here is maybe she'll talk to VIP 4, and then VIP 4 will proxy back to her mailbox, which is still in North America. Obviously, we're not going to move people's mailboxes as they travel around the world, so we're just proxying across, in this case, the WAN to get her to her mailbox. But it's okay that it's a WAN proxy because it's HTTP, which means it's reliable. It is not sensitive to high latencies, largely. It can work in low bandwidth environments. And the beauty of this is this will work no matter what client or what operating system she's working on. Okay? All right. And we'll talk a lot more about that in the HA session later this afternoon as well. But the benefits, as you can see, it really simplifies the network architecture for you. Okay? You don't have to worry about the network being just perfect. We don't want to treat the network as a black box anymore. We want to be a respectable network citizen with this new design, and that's part of what we're doing here. And as I mentioned, it gets rid of the need for the RPC CAS array namespace and the RPC CAS array object itself. And it gives you that deployment flexibility where you now no longer need to deploy a CAS in every site containing a mailbox server. OK, so that's part of it. We've talked about the HTTP and a little bit of the UM aspect. But there's another component in CAS. I mentioned it earlier. It's the SMTP stack. We call that FETS, the front-end transport service. Okay, and the front-end transport service, that's there handling all of your inbound, and if you configure it, all of your outbound traffic as well. Okay? You'll see, though, it's not the same as hub transport. We'll get to that in a minute. It doesn't queue mail locally. There's no mail.queue file. So if you look on any CAS server, there's no storage that we use there. There's no session state that we keep there. It's completely stateless. It's literally just a layer 7 SMTP proxy. But don't be confused by that. That doesn't mean you need a layer 7 load balancer. Okay, layer 4 load balancers are fine. What we mean by that is that there's actually sophisticated routing logic inside of FETS that does the layer 7 load balancing for you. Okay, so you can certainly put the layer 4 load balancer if you want, for instance, high availability across the default or receive connectors. But now we give you the same mechanism to use the layer 4 load balancer, even though the application is doing layer 7 load balancing on top of it. And it'll list it on the same ports that you're used to. We still have the same default connectors, 25 for the default receive connector and 587 for the client connectors, all of which can be changed. So it's somewhat similar to portions of the hub transport service or portions of the edge transport server, but it's not all of that. As you can see, it's actually a very clean and simple type of architecture that is really just made up of the two components, a receiving mechanism and a sending mechanism. Okay, and inside the receiving mechanism are two things. One is the protocol agents. Those are doing things like connection filtering, sender filtering, recipient filtering. Not content filtering, though. We don't examine the content here. We're just looking at some of the elements. We do some anti-malware, some anti-spam, but largely we're not looking at the contents. We just want to look and see first, should we accept this message? And if we do, where should we proxy it to? That's largely all we're looking for here. And then the other component, the hub selector, that is there so that it can choose which mailbox server that contains the hub transport service it should send that message to. Okay, so it's not the categorizer. The categorizer is different. This is just some intelligent routing that we have here through the hub selector. And the message flow is pretty simple. You could have a message coming in from external SMTP. It'll be received, or the communication will be open. The protocol agents will run it. The hub selector will select the appropriate destination, the right mailbox server to send it to. Then it'll pass it over to the SMTP send, and we'll do an SMTP to mailbox. And again, yes, SMTP to mailbox. Not mapping to mailbox like we used to do with the store submission and the store driver. It's SMTP to mailbox. The only place we talk mappy anymore is inside the product when we're talking one component directly to the store. Otherwise, we're using the native protocols to communicate. So in the case of SMTP, we simply send that SMTP to the mailbox server, which then has the transport service on it, which is the full transport stack that I'll talk about in part 2. Now, we can do the other way as well. If I'm on a mailbox server and I send a message through my client, again, that's going to be picked up by the SMTP receive. It's going to be run through the protocol agents, and then it's going to be, if you have it configured to do so, sent to the SMTP send component, and then off to an external recipient. You do not have to let the client access server proxy outgoing mail. It's a configuration that you turn on if you want it to do that. Otherwise, you can just send mail through any other means that you want. It doesn't have to all flow through the client access server. So let's talk a little bit about delivery groups, because that is how the hub selector knows where to send that message. So a delivery group is actually not new in Exchange 2013. We had them in 2010. We had them in 2007. But don't feel bad if you never heard of them, because we never called them that in those products. So if the term delivery group is new to you, it's because we've only dropped it on you with this version. But the concept is not new. We've been using that concept for Exchange for a while, and it basically refers to where we're going to send the message to next. Okay, so there's three delivery groups that we work with in 2013. The first one that's the simplest to work with, that's Active Directory site. Okay, it's the same routing topology that you have with AD. That is the simplest type of delivery group to think about. The next delivery group would be the mailbox delivery group, and that is always going to be either a group of Exchange 2013 servers that are not in a DAG, or any Exchange 2007 or 2010 servers that you have in that site, whether or not they're in a DAG. And then, of course, the last delivery group is the DAG itself, and that is for any Exchange 2013 mailbox server that's a member of a DAG. Okay, so those are the types of delivery groups we use, and based on the recipient, that determines what group we'll use and therefore where to send the message. So you look at the recipients. If the message has a single mailbox recipient, that's the simplest case. We just go ahead and look for any mailbox server within that local AD site. Okay, not a big deal. It's pretty simple routing. If there's multiple recipients, then we'll look for the mailbox server in the closest delivery site. So we'll figure out what site each of the recipients are in, and then we'll figure out, based on the site that the CAS is in, we'll figure out what mailbox server to send it to, always giving favor to the local site. And then the last one is if there are no mailbox recipients, so that would be like in the case of a distribution group or any mail-enabled user object where we don't have actual mailbox to send it to, we'll just select a random mailbox server, giving preference to the local AD site if there is one. Otherwise, we'll send it to the next closest site after that. And it's at that point, once it gets to the mailbox server that you'll hear in part 2, that's when we'll do things like categorization, bifurcation, et cetera, transport policy, and so forth. So up to here, all we're doing is opening SMTP communication and then figuring out where to connect it to. What mailbox server do I need to proxy this to? The benefits that you get, well, now you've got one central point for ingress and egress of all of your SMTP messages. Okay, you don't necessarily have to use something out in a perimeter network, although you can. You don't have to necessarily use an edge server, although you can, and that includes Exchange 2010 Edge as well. So the choice is yours. It also gives you the connection filtering, sender filtering, recipient filtering, and so forth. So you do get some protection mechanisms at the entry point into the transport pipeline. Again, it's not doing content filtering. That heavy work is done on the mailbox server. And it avoids any unnecessary hops because it's always trying to get it to the very best destination endpoint. Okay, it's going to figure out which delivery group is best, again, based on the recipients of the message, and do everything it can to get that message as close to that destination endpoint as it can, okay, by eliminating the hops. And by the way, when we talk about hop, typically we refer to the store and forward, where it sits in a queue and then moves on. Because we're not doing that with CAS, we don't consider CAS to be an actual hop. It's just an SMTP proxy. So it's not going to show up as another hop in the message headers. The only place you'll see CAS in the message headers is if you do decide to configure CAS to send your outgoing mail, in which case all of your outgoing mail will appear as if they came from CAS. But that's fine, because that's the last server that processed it and sent it on its way. And we have to tell the destination what server they're talking to do that. But otherwise, for inbound mail, you won't see CAS in there at all because it's not an actual hop. And this is highly scalable. And I know it sounds funny to say, oh yeah, it's scalable, just add more of this and you get it. But that's the simple reality. This will scale very well, and the whole idea is to have these bricks where if you need more, you just add more bricks, and you scale out that way. And if something happens to a brick, you can quickly, very quickly replace it. Whether it's a brick being a mailbox server or a brick being a CAS, they're very, very replaceable, very modular, very scalable, and whatnot. Okay, so with that, that is the end of part 1. Let me just do a little quick check on time here. We've got about 7 minutes left for questions. So let's go ahead and start them. And I do have some giveaways, too, as well. So if you have a very good question, there's a good chance that you'll get a giveaway. We've got 2 radio control cars to give out. Now, how many of you have had a chance to download the Exchange 2013 preview already and try it? Or maybe the better question is, how many of you have not been able to do that? Okay, wow, that's a lot more than I thought. Well, I didn't bring that many keys, but I do have USB keys that have the preview bits on them. So I've got 4 for each session I'm going to hand out. But you're going to have to ask a question to get one. And it's got to be a pretty good question. It can't be something like, what's your name? Okay, it's got to be something about the session, something about Exchange. And you'll want to do it quickly, because if time runs out and I still have swag left, it's just going in my suitcase. So, yes, sir? That's an excellent question. So I'll repeat it, because I'm sure you didn't hear it. Virtualization. Are there any guidelines for Exchange 2013? Yes, there are. And I'm going to be covering them in the deployment session on Friday. But that's definitely a key-worthy question. So I'm going to throw this at you. It's pointy. Be careful. Awesome. Yes, sir? Is Outlook 2003 no longer supported? Another excellent question. That's correct. The supported clients from an Outlook perspective would be Outlook 2007, 2010, and of course 2013. 2003, maybe it'll work, maybe it won't. We don't test, we don't support. Your mileage may vary. It could not work at all. We don't really know or want to know. But yeah, you won't be able to use from a support standpoint, Outlook 2003 against 2013 Exchange. Catch. Okay, 2 more keys. Oh, nope. Hold on. I have to call on you. But it's okay. If you don't get a key, you might get a chance to win a car. Yes, sir? Another excellent question. Edge transport. You heard me mention Edge earlier, and those of you with a keen eye, in my new diagram, you probably saw that Edge transport server up on the diagram. At RTM, there is no Exchange 2013 Edge transport server. Our expectation is to deliver that post-RTM. I can't tell you when or what shipping vehicle, but it's a post-RTM deliverable that we expect to deliver. Until then, you can use, as I showed in the slide, Exchange 2010 Edge transport server. So if you are on 2010 now, and you're using Edge already, or if you're on 2007 and you've got Edge and you want to move forward, you don't have to touch Edge. You can just let Edge do its thing, and Edge can send messages to CAS, CAS can send them to Edge, and vice versa. Pardon me? Edge subscriptions, so I am going to not answer that because I'm not 100% sure, and I want to make sure I only say things that I'm 100% sure of. But if you send me an email, I'll get that for you offline. And I'm not going to throw this that far because there's a lot of people in front of you. So I'm going to leave your key right here, and I'll remember you. Okay, 1 key left. Let's see. Let's go way in the back. The gentleman waving his hand right there. Yes. Sure. So the question is, do we have any tools or anything in 2013 to do migrations from Notes or some third-party messaging system? So you may have noticed in the last couple releases, we have tapered off more and more with those kinds of tools, in large part because the partner space does a really, really good job of handling a lot of those migrations. There's a lot of companies out there. Quest is a very popular one that comes to mind with their tools. So there's nothing that we have at RTM that is going to help you with Notes migrations or migrations from non-Exchange messaging systems. But we do expect that space to be filled rather rapidly by partner offerings, who we work with very closely in developing that too. So we will have something, it just won't come from us. It'll be a third-party thing that you purchase. So, and that's way too far. I'll keep this up here. Okay, so I have to have a car-worthy question now because these are really cool. But what that means, though, is I'm going to ask you a question, and I'm going to try and see who puts their hand up first. I'm going to do my best. And so the first person to get these right will go ahead and get their cars. So, phones down, no researching the answer, laptops closed. Okay, what is the major and minor build number for the Exchange 2013 preview? Come on, you gotta want it. Okay, let's start with the major. Anybody know the major build number? Come on, what build was the preview that we released? Back there. No, that's the code name. Next. Yes, sir. No, not even close. Yes. Nope, still the code name that he said a moment ago. Yes. No, I'll give you a hint. It's a 3-digit number, the build number, the binary build number. I'll give you another hint. It starts with a 4. Anybody? No, but you're moving in the right direction. Okay, let's try something simpler then. Oh, so close, but no. So close. Yes. 4 what? 413. No. Yeah. What? Now you're just guessing every number in the 400 range. All right, new question. It was 466.13. Okay, that's the build number of Preview 2. Okay, what day did we release it? And I don't mean the day that we blogged about it. I mean the actual day that we released it. Yes? No, not today. Yes? No, that's in the future. No. I'm talking about something that's already happened. When did the preview get released? Yes. What's that? No. You didn't say the year, but that hasn't happened yet either. Yes. Oh, you're so close. You're so close. Yes. No. 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 I guess I'm going home with 2 cars, yeah? Or I have 4 to hand out in the next session. Okay, let me think. You got any questions? You got any brain stumpers? Let's see here. Okay. Yeah, that didn't work out too well either. Okay, I'm going to hang on to the cars for this session. The next session, or the one after that, or the one after that, that I'll do. I'll have all the same number of cars to hand out, more keys to hand out as well, and better questions to give you guys a more sporting chance at winning. No, it's okay. We'll get you next time. Okay, hope to see you at part 2. And wait, before you leave, I don't know if I mentioned this earlier, but again, the HA session tonight is the last session. We're going late, okay? I'm not going to cram it in 60 minutes. You can leave after 60 minutes, but I'm going to go 75 at least tonight. So hope to see you for part 2. Thank you.